So I'm going to talk today about how I think we can move beyond spaghetti infrastructure code bases and some of the kind of forces I think are at play that lead to the situation. And I'll describe as well the situation and some ideas I have about moving beyond that, basically. So just to give you an idea of my journey, where I'm coming from with all of this. So I kind of was messing around with infrastructure automation and things before it became, like, before the term infrastructure as code emerged. So I was playing around with tools like CF Engine and FAI install and so on. If anybody here know about those tools, just out of curiosity? Some little hand wavies and nods. So I could automatically provision machines in the data center, like physical servers, and install OS and configure it and all those kind of things, and then Puppet and Chef and so on. And then around 2009 was like this inflection point. So AWS had released the early stuff was out and it was usable, and we were starting to use it. Some of the companies the company I was working with at the time, infrastructure as code, DevOps, continuous delivery, all of these concepts emerged, even where things, maybe the ideas had been around before, but like they kind of had names and started getting traction in the industry. And so I joined ThoughtWorks in 2010, basically because this was kind of a good opportunity for me to work with different clients, different companies, taking the stuff that I'd been messing around with before and trying to help them to adopt it, because that was becoming a thing. I wrote the book Infrastructure as Code, and the first edition was published in 2016, and the second edition was in 2020. Third edition I'm working on right now, slogging through that. Should be out early next year, I think. And that was really about taking things beyond, obviously, the clients that I was working with directly, and trying to kind of share ideas and thoughts about how I believe this stuff works and can work, more widely in the industry again. And so in the past few years at ThoughtWorks, I've got a role as a kind of a community practice lead globally, and this has given me the opportunity to work with clients and teams, lots of different clients and teams basically, and kind of get ideas and so on. And my kind of current thing, I guess, is I'm exploring and sharing what's next. So it's like I'm kind of like seeing things that I'm seeing that I find frustrating and people find frustrating, and thinking about what can we do better, right? And so that's kind of the idea of this talk. And so I'll try to, hopefully I'll have time to take questions at the end, but we'll see. This is kind of this is actually a fairly kind of new talk for me in terms of I'm putting it together in a way to kind of share it and hopefully get feedback from folks. So also I'm happy to kind of hear people's thoughts afterwards. So my kind of basic premise is that infrastructure code bases that we tend to have, most teams that I work with or meet, people that I talk to, and even ones that I'm on, our infrastructure code bases are just too messy, right? It's partly that we're writing all infrastructure code very custom for everything that we do, rather than necessarily being able to kind of reuse and share stuff as much as we might like. But also, like, even the tools that we use to run and manage our infrastructure, like everybody has like these very custom scripts, make files or whatever, and so it's just like everything is we're kind of doing everything from scratch, and so it feels like we're not really at that kind of point of maturity that even like with software development, where we are. So this is where I feel like we really have a ways to go with this. So problems that we see is, again, too much custom work. Infrastructure is often seen in organizations as a blocker, like getting environments created or changes done and so on, or are things which are kind of something that slows us down rather than helps us to kind of move quickly. The costs aren't always well aligned. By that I mean not just there's a lot of attention on cloud, FinOps and those kind of things around the cost of the cloud vendors and resources, but there's also just the kind of cost of ownership and how it kind of scales as our organizations scale, and all that is, it's just too much. And we often don't have the confidence of our organizations in terms of the systems. Are they stable? Are they going to be reliable enough? Are they going to scale when we need them to scale, and so on? Are they compliant with the things they need to be compliant with? So there's often very low levels of feeling like everything is really in good shape, right? It's all kind of it feels like it's coming apart at the seams a lot. And legacy accumulates, so keeping systems up to date, whether it's databases, core systems, whatever, keeping up with them is really hard. So where we would like to get to is we want to be able to kind of share more infrastructure code within the organization and ideally across organizations. We want to empower teams. This will be one of my themes a little bit is helping teams who are using the infrastructure to kind of do it on their terms and be able to kind of help themselves, basically. Building governance into the system, so rather than kind of building things and having somebody come and tell us where the flaws are or whatever, that it's something that's kind of inherent in how we work on our infrastructure code, how we deliver it, how we deploy it. Lower the costs of scaling, and here I don't just mean scaling in terms of the number of users of the system and the capacity. I mean, as we put more workloads onto it, run more things on it, have more teams working with it, and even as we do things like going into maybe different markets, different products and so on, where you have multiple instances of things, often this is where things get really difficult in terms of that kind of, again, that cost of ownership. So a lot of times, the clients that I work with, where they're gonna go, okay, we started out in this one country, maybe we started out in the UK, and now they wanna roll out in other countries. It's like each country they end up having to, for whatever reasons of kind of local regulations or this or that, they need to they kind of copy the infrastructure code over and maintain it. So everything kind of like grows linearly, and even like people, we're gonna need a separate team to manage the infrastructure for each country that we go into. That just doesn't feel like kind of where we wanna be with infrastructure code. Then in terms of that legacy, if we could be continuously updating from everything from kind of like patches and the very kind of low-level basic system updates to the higher things, upgrading of the kind of, the stacks and so on that we use, to basically get away from having to do big bang, transformations every few years, which are very kind of risky and expensive and disruptive. If we can kind of do that more continuously, it'd be great. So how are we going to do this, right? So I'm going to talk about three kind of areas of things, so three kind of parts to what I'm going to talk about today that all join together. So one is rethinking the architecture for our infrastructure as code, how we deliver it, and then how we do deployment, how we deploy infrastructure code and do provisioning and so on. So I think there's changes to all of these. So in terms of architecture, the big problem that we often have here is these monolithic infrastructure code bases and monolithic deployments. So when I talk about an infrastructure monolith, it's not just that it's a big project, say, it's that we have the infrastructure for different workloads that are all kind of deployed together, and not just infrastructure that's kind of shared. It's one thing if it's shared, if it's like a Kubernetes cluster or some kind of shared networking, that's kind of makes sense. But if you have, like, say, this application is using a database, this application has, I don't know, virtual machines or whatever, and those are all defined inside the same deployable infrastructure code project, right? What you're having there is you've got kind of low cohesion and high coupling, right? So it's like, basically, if I'm going to make a change, I need to make a change to the database for this application. That means I can potentially impact the infrastructure for other applications that are running on it. And while there are kind of features in infrastructure as code and the tooling that we use to help us manage that, so for example, we have, you can say that, well, if I only change the code for that database, it's not going to affect the code for this virtual machine. Well, if you've worked with infrastructure code, that's not always how it plays out, right? A lot of times something changes that you didn't think should have changed. But then you can run a plan, like Terraform plan or some kind of preview command that will tell you, well, that's going to change. But the point is that this is like a cognitive load, or a cognitive overhead of like, I just want to change that database. So why do I have to kind of like be kind of combing through the output to make sure that I'm not going to break something else? What if that does change, something else changes that I don't mean to change? I have to go and kind of track down why that's happening. And it's like, why, I shouldn't have to think about that. I should just be able to think about just the thing that I'm actually trying to change. And so all of this creates barriers to making changes. It means that, we need to have like more governance. We need to kind of have coordination. If you want to deploy a change to the infrastructure that we use, then you need to kind of discuss it with everybody and so on. This makes barriers to change are barriers to quality, because if it's hard to fix something, if it's hard to make changes to something, if there's a lot of process around that, that means it's going to be harder to make fixes to it, improvements and so on. And so you end up accumulating technical debt and so on, because it's just, you just kind of build up the list of things that we need to change at some point. So how many folks use Terraform or have experience with Terraform out of curiosity? Yeah, okay. That's most people here. So the things that I'm talking about apply kind of regardless of tools and specific tools and regardless of like the cloud platforms. But Terraform is like kind of the 800-pound gorilla in this space. And also it has a lot of the kind of design issues are that I see are kind of driven by that because it kind of drives the mindset of how we think about infrastructure and infrastructure as code. So one thing is that when I go to a client and it's like, oh, we have a big Terraform project, and it takes like, I've had a client where running Terraform apply could take 2 hours to complete because they had literally 60 MySQL RDS instances in one file within this project. And so the kind of first conclusion was, well, hey, let's break it up into modules, right? We'll use Terraform modules like libraries, right? This will help us kind of make it, nicely structured and modularized code base. Well, the problem with modules and any kind of library type thing is that they, you're still deploying them all together, right? You're still going to run your Terraform apply. It's going to pull all those modules in, and it's still going to kind of, still going to have that 2 hour or however long deploy and that blast radius, so that risk of breaking something that you didn't mean to change. So that doesn't really solve the problem, that I'm talking about. It's great for organizing and sharing code. So it's not that there's no kind of purpose to them, but it doesn't help with this particular issue. So what we really want to do is kind of break up, and this is familiar from like with software monoliths and so on, where we talk about microservices or at least smaller services and smaller divisions of things. So we want to do the same thing with our infrastructure, have multiple deployable projects, deployable components that we can develop separately, test separately, and deliver into our kind of system separately. And this is it's not like a new like insight or whatever. It is something that we do on projects, but I think it's that, again, the tools aren't really designed to make this really easy to do. So we end up having to do a lot of extra work then to kind of make this all work. And what we really need to do to help this work is kind of more helpful abstractions. How many people saw Jim's talk earlier this morning? Because so Jim Barrett was talking earlier around some things like abstractions and a lot of different topics, which I think really it was kind of nice kind of feeds into this, right? So I'm taking a lot of the concept that he talked about and thinking about how do we apply it to infrastructure. So the thing about abstractions is they can be controversial when you talk about these abstractions and platforms. And so I think the important thing to remember is that abstractions are not helpful if their purpose is to hide things. Developers are too stupid, right? They don't know this stuff, and so we'll hide it for them and not let them know what's going on. We'll just give them a black box. That's not helpful if you can't see it and understand what's going on underneath. Or if they're there to disempower people, like we're going to force people to do the right thing. Again, they don't know the right way to use infrastructure, so we're going to force them to use it or to structure their applications, and so we're going to make them do it the way we think they ought to do it. Again, that's not helpful. To me, the important thing with abstractions is that kind of context and the cognitive focus. So if I'm working on the business logic for an application, I don't want to have to be thinking at that point about network routes and routing tables and how all that kind of low-level stuff works. I might need to, so I might be working on the business logic, and I might deploy it and find it runs slow, and so I want to be able to have the visibility into what's going on and to be able to understand it and troubleshoot it and maybe even contribute to fixing it. So to me, it's about focus rather than anything. So with infrastructure and infrastructure as code, I think the abstractions that we have, again, with most of the tools that are out there, are not really helpful enough, right? So most infrastructure as code is really low level, right? So it's really kind of dealing with very, the kind of primitive concepts of what the platform gives you. So routing tables and routes and gateways and these kind of things. And that's great for systems administrators. I think especially a tool like Terraform, I think it's kind of targeted at and written by people who think in these ways, and it makes sense to them. Kind of developers and people who are responsible for deploying applications and running them and all that kind of stuff, they're not necessarily thinking at that level all the time. Right? Again, it's about context and what you're trying to do at a particular point in time. So to kind of put it visually, if you think about, okay, you've got your application that's running, and what it really cares about is just the infrastructure resources, just the things that the cloud platform provides you, via the API, the kind of, those low-level primitives, right? And when you run your infrastructure as code, however you've organized it, however you've delivered it, at the end of the day, you end up with just this is what you end up with, right? And so this is the raw, what's happening. And when we think about code, so stacks is the term that I use for the deployable unit of infrastructure code. So CloudFormation and CDK and Pulumi, they all talk about stacks. Terraform doesn't actually have a term for this. It's kind of at the code level, it's a Terraform project. You have a state file which correlates to this. You have a workspace which maybe contains things for managing this. But when you talk about you ran your Terraform project, you ran apply, and you have some resources out there, you don't really have a term for that collection of resources. What is it? And to me, this is a symptom, right, of the fact that, for Terraform in particular, this is one of the most important concepts in terms of a unit and a module that we work with when we're working with infrastructure as code is the unit that we deploy, as an independent group. And the fact that it's kind of not defined and kind of treated as a first class, object or what have you in the Terraform ecosystem is why I think one of the reasons why we struggle a bit. They focus on, modules is the thing that they provide you, which is not necessarily, you can use it as a deployment unit, but that's not what it's designed for. So, what happened here? Okay. Right, okay. It wasn't the screensaver because that was still on. There are cases where, what's interesting, so when I talk about how this is not treated properly, I think it's interesting that a lot of the tool, or some of the things so if you're familiar with TerraGrunt, this is one of the most popular tools for helping you to work with Terraform projects. One of the main things that it does is it gives you a way to take a Terraform module and use it and deploy it as a deployable unit. It gives you a structure for doing that. And even HashiCorp themselves are coming out with, so they have a feature called no-code deployments, which is basically take a module and deploy it. And they basically on the kind of behind the scenes, this is on their cloud offering, the kind of commercial offering they have. You can get the access to this feature where you can use a module as a deployment thing and it will kind of generate the stack stuff for you. And so again, I think those are kind of indicative that this is an important concept and I think most of the things that we're being given are kind of hacks to kind of help us to do this. So anyways, there's another thing which I think is emerging in terms of levels of abstraction out there, which is I'm calling infrastructure products because there's not really, it's not got a lot of, there's nothing out there that I've seen that kind of talks about this at this level. But there are a few products that have features for this. So Pulumi has Pulumi applications, which is basically a set of, lets you define a group of stacks they call microstacks and deploy them as a unit and provide them as a unit. Let me say a little bit more about what it is first. So basically the idea here is it's potentially a collection of stacks. It can't just be one stack. You can't just say I have one Terraform project and I want to treat it as a product. But the idea is that it's presented for use, so who's using it? Who's those, say, application developers or somebody who's responsible for that, who isn't necessarily, a wizard with the low-level Terraform code. How do you present it to them? What's useful to them? It's not just around the presentation. It's also what is kind of a useful collection of stuff that provides a service. So you might say something like even just like a database. So you have Terraform code that can define an RDS instance in AWS, but there's usually other stuff that you need to put around that, like security policies and other kind of things. And so if you kind of say we might wrap and present to our developers, look, you can have a database. There are a few different things that you might care about, like maybe it's things like what type of data are you storing? Are you storing personal data? Are you storing financial data? And so do you need different levels of controls around that? You can kind of build that into this level of infrastructure as product and say, I want to deploy a database instance that's going to have personal data, and so it does the right things, the right levels of encryptions and policies around it, versus if I want to use it for less sensitive data, maybe it won't have all of those kind of things. And so I think that's, thinking about that useful level of abstraction for developers, I think is more and more important. So I mentioned Pulumi has something for that. HashiCorp are coming out with a feature confusingly they call stacks. So in HashiCorp and in Terraform, stack is not what everybody else calls a stack. It is basically, it's kind of like a Terraform project that calls other Terraform projects or modules or so on and wires them together. And so I think that's getting at this problem that we need this level, they know people want that kind of level of control and stuff like that up there, but it doesn't really currently implement it in a way that is focused on those users. It's still kind of like for Terraform users, system administrator types, to be able to kind of, it's a convenience for them rather than for the users, if you see what I mean. There's a couple of other tools I'm going to list at the end. Like I have all these kind of tools which I think are interesting and potentially useful for some of this stuff, and some of those also are kind of targeting that level. So I feel like this is an emerging thing. Like I see the need for it, certainly. Most clients that I work with, most projects that I've been with, we've kind of like implement this by hand, with our own kind of custom in-house thing. You have like a YAML file that like says, here's the Terraform projects and how to wire them together. And so I think vendors are starting to see this, some startups are starting to see this and trying to kind of make this happen. So that's the kind of architectural highlights, I guess. In terms of delivery and delivering infrastructure as code, some of the kind of issues it drills down a little bit of a level of the problems I was talking about earlier. Common things that I see with teams and organizations using infrastructure as code is that they find that environments are difficult and expensive to create and start up. And so it's kind of like, we say, we need an environment, we need to do some performance testing, we need an environment for that. The infrastructure team has to kind of go and create that. And it's a project of its own, in its own right to do that, right? It's not an easy thing to do. And then changing them is expensive and disruptive, right? So it's like, we have to upgrade. We're going to take the development environment down for a day or two because we're going to upgrade Kubernetes to a new version. And that's it's a lot of barriers to change. And then because of those barriers to change, often different environments are at different levels, right? We have the old version of Kubernetes in that environment, it's fine. We've got it over here. Okay, you deployed your stuff, it worked there, it doesn't work here, blah, blah, blah. And so that's kind of a common thing where it's hard to keep everything consistent and up to date because of how difficult it is. And then you also get not enough environments. So there's two different things that happen. You have contention over environments. Different teams are trying to deploy their applications and they kind of get in each other's way and break things, or they have to wait on each other. We have a policy, you're going to have to wait for the other team to finish testing their change and their new feature before it's available for you. But then at the same time, in the same teams, you'll see we've actually got environments that are over-provisioned and underutilized. So and it's a funny thing, because these seems like they're kind of like contradictory, but what happens is you get that environment created because there's this demand, and so you have the infrastructure team go and spend a week or two creating that environment, and then when you're done using it, you leave it, right? Because it's too, we're not going to let it go, right? No, we still need that. We might need it later. And so you end up with a lot of environments that are provisioned too large for the purpose, for any particular purpose, and then aren't always used, and then you get those kind of times when everybody's crushing to get it into what's available. So to kind of like talk a little bit about how this happens, there's this, I'm going to talk about the infrastructure delivery lifecycle. And I have three kind of like parts of it that I'm going to talk about to kind of think about how we can kind of rethink this. And so one is where we're developing the infrastructure code, we're writing our Terraform code or whatever, and testing it out and so on. And then we're running we're applying it and running it to create environments or make changes to environments. And then there's the teams who are actually using it, deploying their applications on it and so on. So these are kind of like three different parts of the process, really, the life cycle. And so I want to talk about recoupling it, right? So currently, the way it's coupled is kind of like this, right? So most of what I see and most of the way that I think infrastructure as code tools and most of the kind of training materials and examples and tutorials you see out there are kind of aimed at this idea of you're going to write infrastructure code for very specific, it's for this one application and this one environment and working in this one way. Maybe you reuse the code across multiple environments, but you probably have stuff that's fairly hard-coded. And so it's all very bespoke. And so this is kind of okay when you've got a smaller system and a smaller team where there's really high levels of collaboration. So we need we've got, application developers can talk to the infrastructure teams so that they can make the changes to the infrastructure code so that they can deploy the next, the change that they need to their application. and they work closely together. So that's kind of okay at a certain level. But it does create a coupling across the life cycle this way. And it's at scale where it starts to hurt, right? Because at that smaller scale, you might not even have different teams, right? We have got the one team, and we work on the infrastructure, we work on the application code, and everything's cool. But as you get more and more workloads deployed onto the thing, and more teams using it and so on, that's where it starts to make that collaboration a lot harder. And so that's where you start getting, well, we need a separate infrastructure team now. And that infrastructure team is going to have to start working, you're going to have to kind of raise tickets or get things added to their backlog. Oh, you need this change for your database, for your application, like I mentioned, because of this new feature that you're working on. You're going to have to wait because they're working on the next, the upgrade to the Kubernetes cluster, and so you have to wait till they're done with that project before they can get around to your thing, right? And so, this is one of those things that happens. It kind of drives silos and drives kind of bottlenecks and frictions between the different people and the different teams. So the situation we have is that we've deployed, we've kind of coupled this way. And what I think we need to do, and in some cases we've done this on some of our projects with some of our clients, is to so what I'm saying here is just that the responsibilities are this way, right? You have the one group or the one set of responsibilities, which is around developing, configuring, and deploying your code, and then the other is getting your application to work once they've done that, right? So what we need to do is what we should be looking to do, I think, is to change the coupling the other way. Yeah. So if we can have the responsibility for developing the code, and then on the other side, responsibility for configuring, deploying, and using the infrastructure kind of together, this is going to enable us to do more of that kind of self-service kind of model and so on. Some of the things I'll talk about. So the idea is that you have people working on infrastructure code, and this is deployable components, so it's not just modules. Again, this is about stacks basically, or infrastructure products, whatever kind of works for your particular system. And it's saying, let's develop those, let's have pipelines to test them and make sure that they're proper and so on, and then make them available to be deployed. And so you put them into like a repository or what have you. And then you've got your team can kind of configure for themselves, okay, this is what I need. I need that database to handle sensitive user data. And here's the module that I use that I've been provided as a stack or an infrastructure product. And so that's what I'll use. I'll talk a little bit later about different ways that gets implemented. So you take that, and then this is where you get into when I talked about the monolithic infrastructure broken down into different pieces. You get those kind of different components. So different components might be developed by different teams and made available. And by the way, one thing I want to emphasize: this isn't necessarily just it doesn't necessarily mean that. It's a team division, right? Like, so this is kind of responsibilities, but you may have teams who have special needs in terms of infrastructure. So often you have, like, say, teams of like data scientists and so on, who are going to use some special, they got special tools and databases and so on and products and things that they need the infrastructure for, and they probably have the experts who know that. So they would, build these things. So it's not that they can't, make infrastructure, but it's just that here's kind of the process and the life cycle for that infrastructure that defines, here's how you build a deployable infrastructure component, for your own needs, and then here's how it kind of gets managed through the process and deployed. So that kind of final point then, or final part then, is how do we manage the deployment of these things? And so I like this idea of application-driven infrastructure deployment, which I'll talk about. So the contra to that, what we tend to do is what you can call bottom-up infrastructure deployment or bottom-up provisioning. I say deployment because I'm also talking about changes and things. It's not just provisioning a new system. It's deploying that infrastructure code to make changes to your infrastructure. But what typically happens is, and this is tied in with all the things I was talking about before, the monolithic infrastructure, that kind of separate team that's owning all the infrastructure for all the things, is that the process for creating an environment and making a change to an environment is getting the infrastructure team, they create the environment, they deploy the code, they deploy the changes, and then once they're done, then application team, okay, the environment's ready, go ahead and deploy your applications and so on. And this division gets really, really difficult, really harmful, right? So you'll see situations. I've certainly seen situations where, so I was at one client a year or two ago now, where they had a group who was responsible. It was a separate company, so you can kind of see, they were responsible for the infrastructure. And so you can kind of see the pressures that come onto this, right? Because this seems to a lot of people like the right thing to do, right? So infrastructure and software, like they're different things, and so you want to separate the concerns. Application people, like even I said, you don't want to be, having to own the infrastructure, so you should separate those things out, right? And so you get a separate company to do it, and so when we went into this particular client who had this group working on their infrastructure, and I was going to organize a workshop, and the first thing I asked them was, well, let's talk about the applications that run your infrastructure. They got pissed off at me. The guy who was in charge was saying, like, you're wasting my time. Like, I'm not here for applications. I make the infrastructure. Applications are not my problem. Go and talk to the BAs and then come back when you want to talk about infrastructure. And I mean, they had a lot of problems because of this kind of division, right? So they were building infrastructure based on what they thought was important. They thought it was important that every country that they roll out to needs to have completely separate infrastructure with no data leak between, because there's, we know there's like data, protections and regulations and so on. So there's no way to get data from one environment, from one country to the next environment. The people who are responsible for the product, who are also not very open to kind of collaboration across those silos, they assumed that customers would be able to use their product as they went to different countries, because their customers would tend to travel between countries. And so because they weren't talking to each other and refusing to talk to each other, they were obviously heading to a bit of a disaster. They also had a problem where they were worried about the capacity. They wanted to go to China. It's like, I'm going to have loads of users. We need to have the capacity. We're not sure. We think our system isn't going to hold up to it. And so the infrastructure people, they went and they provisioned an environment to test it in, scaled out everything as massively as possible, and did load testing on it. Not with the application. They didn't deploy the software on it. They tested their infrastructure. Said, our infrastructure can handle the load. Not our problem if the applications can't, right? And it's like, well, you need to be holistic, right? Things need to kind of work together, or else you are going to get to trouble. So obviously I don't like that. So the idea of application-driven infrastructure is to kind of empower the application teams. And so what you want to do is you say, when we deploy the application, the infrastructure that it needs can be automatically provisioned or updated or what have you for use. And so this isn't about the application developers needing to know how to build all that infrastructure. It's just giving them the ability to use it when they need to, and to kind of configure it to the level that makes sense to them in the way that they need to. And so again, this kind of can work with kind of different workloads, multiple workloads. We can kind of share infrastructure across. Well, can we, right? So if we're deploying infrastructure when we deploy an application, what about infrastructure like, say, a Kubernetes cluster or shared networking or so on? Like, when does that get deployed? And so the kind of next bit in thinking about this is thinking about contexts for deploying and configuring infrastructure and these infrastructure components. And so one kind of context is that workload specific stuff. So this is what my application needs. My application needs, maybe it needs a virtual machine that is just for it. Maybe I need some networking ports open, so I'm going to take inbound connections. Maybe I need DNS and so on. I need a database instance and so on. And so we can define the infrastructure that's just for that application. In that context, by the way, again, so I'm talking about things like context and infrastructure products and stacks and so on. And I think it's not important. What I'm not trying to do is to kind of make a lot of complexity in terms of, you need to have all these different layers. It's just ways of thinking about it. And it might actually be just a simple thing. So it might be that this is just one stack. Each of these is one Terraform project. Or it might be multiple, right? It depends on what you need and what the level of complexity that you actually need for what you're doing. So then you can have a context for shared infrastructure. So, okay, this is the things that we need together. And so we'll define again, one or more deployable components that make up the things that our different applications or workloads need. And you might get into, as you kind of get into larger organizations and more complex requirements, you can say, okay, we've got a couple of different application groups. Maybe they each own their own kind of set. Maybe it's the same component, so maybe they each have their own Kubernetes cluster. Maybe we're using the same infrastructure product to deploy the Kubernetes cluster. So we're sharing that. That doesn't mean we need to share a single instance of it. It might make sense in our use case to have them separately. Different teams can kind of manage them for themselves. Maybe we have some infrastructure that's shared at that level. So maybe this can be like if you have like an environment or accounts or those kind of things that you define contexts for those and what infrastructure components say need to be deployed at that particular level. And then things like platform services to me also kind of fit into this. So I tend to look at platform services like say things like monitoring or identity management or whatever as potentially like applications, or they might be like SaaS hosted things or what have you, but it's like they're just another application that need infrastructure. And so this is the model. We can use the same model for that infrastructure as well. So again, the right thing, the right level of what you need for your organization rather than the needing to fill in all those kind of boxes or multiple, like there could be more layers if you need to in a very large organization. Some kind of, I guess, guidelines or thoughts on how to kind of use and design this stuff. So one is that infrastructure should be defined as close to the workload as possible. So you only kind of bring things down into like a shared level when it actually needs to be shared. I think this is an interesting point because one of the things that you put in at these levels is things like controls and security policies and those kinds of things, which I think a lot of instinct is, well, they need to be down here because it apply. You need to have, it's security is like a high level concern, right? And so when it comes to things like, say, a network, a firewall port, we need to open a firewall port for this application. That needs to be defined with the application because that's specific to the application, not down here. So this is not a hierarchy of kind of control and authority and so on. This is just a, where do things get deployed when they need to be deployed? Because when you do this, you could do kind of, partial deployment. So if you're testing one application or one couple of applications that you're testing how they integrate together, you don't need a full environment for that. And actually you can deploy it on demand just when you need it. And these low-level contexts should be ignorant of their consumers. So you shouldn't have things in here which define, and here's all the applications of their databases and whatnot, right? So the knowledge should be kind of, the dependencies, because that creates dependencies, right? If this knows about these things, then you have a circular dependency, and so you want to make sure your dependencies go in just one direction. So the kind of final bit here is then how do we kind of manage the deployment of these things and options for doing that? And I'm just going to kind of bullet point a couple of things. So one is, as I mentioned, application deployment triggers. And so the idea here is that you might have like a configuration file. Maybe it's in your pipeline. And when your application gets deployed, you kind of push that. So we've done this kind of thing in a couple of clients. We have it's usually like a YAML file, right? And you might even use it in conjunction with like tooling for like GitOps and so on. So maybe you have an Argo CD that reads this file and manages the deployment of the infrastructure for the application. Or it can be a pipeline, so it can be in the pipeline stage, it can be a push, or it can be kind of like a pull kind of thing. Oh, I was going to say on the pipeline stage, one thing that you can do here is, again, those different level of context. So you can say, we've got a stage where we're going to for a testing environment for a certain set or subset of the applications. And so that can say, okay, we need to deploy this context, which is the group of applications, the infrastructure for those. And so that's how you can manage those different levels. So let's get a quick sip here. Developer portals can be useful. Actually, I would say the difference here of when you want to do it between these for deploying, say, infrastructure, for deploying an environment, say, is that in a pipeline stage, you can do the ephemeral kind of environment. So you can say, this stage of the pipeline, we need to run automated tests on, integration tests across a number of applications. And so that stage can say, provision, the environment level stuff, the shared stuff, and the applications and so on. Then run the tests, and then if the tests pass and don't need to be, you don't need troubleshooting on it, then you can tear that environment down. And so you can kind of save costs that way. You can save costs by, limiting the lifespan in that way, and also by only deploying just as much of the environment, just enough environment, rather than having to use a full environment, full-sized environment that's long-lived. Developer portal tends to be more useful for those kind of longer-lived things where it's like, okay, I want to set up an environment to do stuff over a period of time. You can still kind of time limit it. You can still say, for a non-production environment, obviously, an environment will be torn down after a certain amount of time, even if it's created by a portal. But this can be useful. So some of the kind of useful things we've done is where you have like a QA environment, and the QAs like to kind of like prepare their test data on an environment. And so you can have it so they can go to the portal and say, I want a test environment, and these are the applications I want to deploy, and then it deploys the stuff that's needed. And then they can maybe work with it over the course of a week or so. They're happy with it, they're done with it. It gets torn down, but maybe the data gets saved, right? And so maybe the next time they go to the portal, they say, I want to create a test environment again, and can you, I want to use that data, the data backup or whatever that was created because I handcrafted my test data that I really like for that. So there's a lot of kind of interesting things you can do with this kind of model. So there's platform framework tools. So there's things like Kratix and Humanitech, which they make tools for kind of defining platform services and so on, and managing the deployment and provisioning of those. And so those you can tie those into kind of provisioning infrastructure along with it. So you can say, okay, I need to deploy a monitoring service. I'm going to use Kratix for that, and it can also part of it's I forget the term they use for kind of like the blueprint of here's how to deploy the thing, but that can include calling out to the the infrastructure code to provide the infrastructure for it. I think I have one last one. Oh yeah. So yeah, how can you use these ideas? Well, the bad news is like you kind of have to do it yourself still, right? There's not anything out of the box that kind of works this way. But the good news is there's lots of stuff out there which is kind of, I think, playing around with this, with different aspects of this, right? And so this is the kind of thing that if you want to take a picture of this. So I'm not vouching for any of these things, or like these are all things that basically I'm collecting a list of tools that seem like they might be interesting or helpful in some aspects of this. And so I have kind of messed with some of them. We've had teams kind of do proof of concepts with a few of them. But I'm not sure, right? So this is kind of like, this is the stage that I'm at. I'm sharing with you, like I'm kind of still working through this stuff. So the stage I'm at is like, I want to see, what toolings, that's out there can help us to do these things better. I'm very keen to hear experiences of people who have, used these kind of things. Yeah. So that's pretty much what I've got to dump on you today. That's the QR code for the feedback form. It looks a little blurry, so I'm not sure if you're going to be able to get it off that. But if you want to give feedback, please feel free to fill out the form. It's the same form, anyways, that you might have seen for other talks. And also, like I said, I'm happy to chat. So thank you. You might have time for one question. One or two. Okay. Okay. Okay.
Stuff that they think of as infrastructure, like serverless type stuff, like step functions.
Yeah.
What we think of as application deployment infrastructure.
Yeah.
I like to do those. Do you see that? Obviously, it aligns well with your infrastructure kind of pattern, but do you see that distinction any more clearly?
I think it probably does depend. It's going to depend on the expertise of the team and so on. I think what I would like to think is that this gives a mechanism, right? So I kind of made the point at one point that this doesn't mean that everything that's below the line, that's in an infrastructure thing has to be an infrastructure team owns it. It can be like, okay, this needs maybe some Terraform code to make it happen, or some CloudFormation or whatever. So here's how you can kind of package that up and make it reusable and deploy it, right? And hook it into the things and make it play nice with other stuff. So it's kind of as much about this kind of how things integrate rather than necessarily being about ownership. So, is there a hand there?
Yeah, so what point you will govern which?
Depends. Depends on what you're trying to govern, right? So I like to push it as close as possible to the thing. So it's like, you have an application and it has, a database, say, instance that's just for it. And so you should have the governance for that should be there. And so it should be you can put it in multiple points, as with most kind of security and governance. So in that package, if you've got an infrastructure code package, which defines that database, you've got a pipeline for putting that in and making that available to be deployed. Like that pipeline should have checks. It shouldn't allow things through that okay, all of our databases need to be encrypted at rest and so on. And they need to have secure, a password policy or whatever put onto it. So that kind of needs to enforce it. And then deployment time as well, you can enforce things like, does it have the things that it's supposed to have? And so, yeah, I think the answer is, multiple points and as close as possible to where it affects. You don't really want to have policies that, I know a lot of people like to have, like, we put the policies into the global level, and you get this with, like, landing zones that the cloud providers have. It's got all the things for everything, and it's like, well, it really loses. It needs to be close.
One last very quick question.
Yeah, so we've got Terraform specific questions.
Oh, okay.
We've got community-based modules. There's a conventional start for getting up quick and going. Community-based modules is a really good way of doing that.
Yep.
Great start with any 5 elements, basically. Move your updates from 5 elements to plan now, adding something like add then you find going back to that off, then you've got the whole cover. And then you end up bringing the content out.
Yeah.
Updating itself, updating the file version, maintaining something else module. Then you find you need to make changes to it, and then it's just your own custom thing to maintain. And that happens a lot of times. The question is, how do you manage that and deal with it?
I think how you deal with it in today's world is pretty much the way you've described. That's how most people deal with it. I think it's an issue. So I'm kind of going like into the bigger, fuzzier aspects of it. I think it's an issue because, again, modules weren't really designed necessarily for that. I think it's interesting when you look at Terraform in particular. So Terraform itself as a tool is built up of providers. Like the functionality that they provide is created by providers, and so providers I think are pretty good, right, as a way of and you have updates to providers and all that, and they work pretty well because it's their own, the phrase, their own dog food, right? HashiCorp doesn't really do a lot with modules for the things that they're selling and providing so much. I mean, maybe a little bit more now with HashiCorp Cloud and all that. So I think it's kind of like, it's not as mature a construct. It doesn't, it's not, I just think that it needs to come along further. I think there's also something to me around the idea that library level, selling things at the library level is kind of hard. And so this isn't as quick an answer. You guys said it's a quick question, but so way back in at the end of the .com boom, the company that I kind of went bust with was, one of the things we were doing was we were working with Java, and we made Java libraries, and we we're going to sell them, and it's like nobody wants to buy Java libraries because they can write them themselves, right? I think the level of what you can kind of reuse and share is probably a bit higher up than that, probably at that infrastructure product level. Here's a useful thing. But even there, I think just the tooling and the ecosystem of stuff needs to come along before that's going to really work as well. So I think that's another symptom of the spaghetti infrastructure that we're in now. Sorry.
Great. Thanks so much, Kief.
Thanks.